That's all right. Maybe you can start the stream directly there, or not really anymore. What do you think?
I probably can, right? Just directly start the streams there. Oh, I don't know that I can actually because I'd have to end the stream. Let me just see if this is picking up audio. Right, just directly. Oh, it is now. Okay, perfect. Is there a way for me to remove this ugly thing from stage though? Hmm. And we've got already a good amount of people here, but I'm gonna wait maybe 5 more minutes before we get started.
Okay.
Yeah, we've got about 20 people on LinkedIn, about 20 on YouTube so far, and about 15 here. So about 60 people so far. Thank you all for joining us today for this event. We'll get started here shortly. And Yi, if you don't mind, can you just confirm that screen sharing is going to work for you? Just because sometimes Discord, when it's a new machine, it's a little finicky.
Mm-hmm. Yeah, let me try now.
Sounds good. Awesome.
It looks like whenever I share my screen, I cannot see this camera view anymore. Is there a way?
I'm not sure that Discord allows that, quite frankly.
Okay.
Yeah.
It's all good.
Okay, cool. So I'm
Yeah,
gonna
give me 1 second.
No problem. Take your time and let me know when you're ready.
Yeah.
All
I'm
right,
good.
cool. So I'm going to go ahead and get started here. Thank you all for joining us. It looks like on all platforms, we've got about 75 people total. Thank you so much for coming out for this webinar. And I see people joining in. So I just want to say hi to JMT, Freestar, Som, Ion Papa, Sabrina, Hansi. Thank you all for joining us. And Yi, of course, thank you for joining us. If you're not familiar with Yi, he is the co-founder and CEO of Relari, which is a company you're going to be hearing about today that's using data to bring RAG systems to production. Yi studied at Northwestern University. He also was able to achieve his MBA from Harvard. So pretty smart guy. And he's got a pretty cool background. If you look at where he's worked, he started working in financial technology, and then he was in a product manager role, and now he's starting this company. And in his free time, he likes to sail, and he's also helped build schools in Congo. It's a cool website that he's involved with called Build a School in Congo. So today he'll be talking to you about how to use a data-driven approach to productize your RAG system. Yi, I'm going to hand you the baton. Take it off. Oh, looks like we might have lost Yi. There we go.
Yeah, sorry. I feel like I, for some reason, faded out for a moment.
Oh, no worries at all. Go ahead.
Can you hear me?
Yep, we can hear you. If you don't mind, just re-share your screen because it looks like it's lagging now.
Okay. All right.
Okay, looks like it's loading. It was just working.
Yeah, in the meantime, I just want to say, thank you for the Quadrant team, Dave and Thierry, for having me here. I believe we met another developer event, I think a month or two ago, and I was also presenting on a similar topic. Quadrant is a very well-known name in the space, and I'm very excited to be here. I myself is a Quadrant user. I think the Rust-based vector database is a really cool implementation, and it's really a key part of any production RAG systems today. So, and I'm happy to share today a little bit about how what role Relari plays in this ecosystem and best practice we have seen of companies who successfully sort of built RAG systems that actually work in production and loved by customers.
Yeah, so I'm not
just let me confirm that.
exactly sure what's going on because it was just working 2 seconds ago. And now it looks like we're getting the Discord dots.
Yeah, let me do this. Let me switch to my.
Okay, no problem at all. Apologies for the technical difficulties, people. You know how Murphy's Law works. Everything is working perfect till you go live. But we should be able to get this resolved fairly quickly. And if anyone has any questions, just feel free to drop them in the chat. We'll be keeping track of them. And when the presentation is over, I'll be sure to make sure that Yi can check out your questions. So if you're curious about any particular point of the presentation, no worries, Yi will be around. And there's actually more people trickling in, so looks like our delay actually is going to work to our advantage. Oh, no worries at all. We can't hear you, Yi, at the moment. It sounds like I just heard something. Yep, you're back now. Okay, we can hear and see you.
Okay, perfect. Yeah, so sorry for the connection issues. Not sure what happened.
No worries at all. Okay.
Is the screen?
Screen is showing. I'm going to go ahead and leave the stage, and you have the floor, Yi.
Perfect. All right. Yeah, so, well, really happy to be here today. And today we're going to talk about quite a lot of different things. The main topic is about RAG systems, but I'm going to talk a little bit about generally the state of LLM and generative AI applications here today. And I'm in the end going to share a case study of like how to make a RAG system for a very specific application work. And in the end, we'll also do a Q&A. So quickly about Relari. So we are a very young company. We started last year, and our main mission is to help people adopt LLM in a reliable and production-ready manner. And the way we do that is through a data-driven approach, which I'll talk a little bit more in the slides. But let's dive in. So I'm sure many of you have seen this particular hype cycle chart by Gartner. Almost all technologies go through this trend of going from initial buzz to a trough of disillusionment and eventually get to the true productivity gain people hope for. And generative AI is very much on the hype of that cycle. And if I can decompose this, if I have liberty to place where RAG is, I think it is pretty much on a downward slope of getting to the trough of disillusionment, because a lot of people have played around RAG systems and feel like they're not really getting that magic that they're hoping for.
Hey, sorry to interrupt. We're getting some people saying that they can't see your screen. So some people can see it, and okay, no, sorry to interrupt you. Go right ahead. People can see it. They just need to rejoin. If you can't see it, please disconnect and reconnect again.
Okay. Yeah. Sorry about that. And Thierry, feel free to interrupt me again if people are having trouble seeing my screen. So if I can decompose this, I think RAG is pretty much, on the downward slope of getting to like nobody is actually that excited to talk about RAG as a new thing anymore. But if you look at it as another angle, that also means we're actually getting closer to the right-hand side, which is making these systems truly bring the productivity gain people hope for. And really, what's the difference between the phase 1, 2, and 3 is obviously expectation. But from a technology perspective, what it is how ready are these systems for usage at scale? Not just for a fancy demo to show people what this potential is about, but actually smoothing out all the corner cases and make sure it's always performing. Now you don't have to worry about the reliability issues, and you'll also get the answers you want in the most helpful way. So how do we cross this chasm to go from demo to production? This is a pretty it seems like a topic everybody's talking about, but it is not a new thing, and especially AI as an industry has been around for decades, and there's a lot I think we can learn from other industries. So both me and my co-founder actually come from this autonomous vehicle industry. So I worked at a company called Pony AI, which was a very large self-driving car company in the Bay Area. And my co-founder, Pasquale, he did his PhD research at MIT. And his research focuses on the reliability of AI systems. And he uses self-driving car as a prime example for his research framework. So in the autonomous vehicle industry, if you look at this chart, what it tells you is this is Waymo's testing mileage before they actually launched the service to public to have people fully take the fully driverless ride. And in that process, they first tested. They tested obviously a lot. If you're living in San Francisco or Phoenix, you see these cars on the road all the time. But what a lot of people don't know is that they actually also tested a ton of mileage in simulation. In fact, 1,000 times larger than they test on the real road. And why do they need to do that? It's because AI systems are. And also, if you make a small change in the code to improve a particular feature, it might actually retrogress in another function. And truly make sure that these systems work reliably. For the self-driving cars, it's technically 1 million miles to make sure it's safer than human for each version. So obviously, that's not realistic to test in the real world. So are safe. And really, also, I don't the risk, but also this is the backbone of how all the engineers in this industry iterate these systems to make fast improvements, to test their hypotheses, what might work and what not work fundamentally. And essentially what we think is that, this doesn't just apply to self-driving cars. This applies to any type of AI application that you want to perform reliably at scale. And for LLMs in particular, we think these are extremely powerful AI systems. And even though the people building applications may not be building the models directly, they still have to deal with the intricacies of the non-deterministic nature of the foundation models, the embedding models, and all the other things they have to pull together to build an application. So this approach should still work for people who are trying to make something work. And I just want to confirm real quick, people can still see my screen. Yes, looks like it's live. All right, so what has Rolari done, and what is our place in this? So we built a suite of tools to help people leverage data in their whole development process. And at the core of it, we use large-scale data sets. And data set can usually come from, like in self-driving cars, a small sample of real data sets. But then we can expand it to a very largest extent with the synthetic data sets. And now you will have actually a very good representation of what your use case look like. And we can use that for, on one hand, very rigorous evaluation of your application to see if it works or not. And on the other hand, to systematically improve the performance of that. So if you do that, you actually take the guesswork out of developing LLM or RAG applications, and you would know exactly what is working, what is not working, and how to make it work better. So let's move the topic to RAG specifically. So this chart is from Quadrant, and everybody at this point, I think on this call in particular, if you're interested in Quadrant and LLMs, you will know that it's actually a pretty simple concept. All you need to do is fetch some knowledge, relevant context from a knowledge base, and feed it to the LLM. And you can build a simple RAG system in like 3 lines of code with any of the orchestration framework. So what makes it challenging? But before I answer that question, let me first talk about a couple of misconceptions about RAG overall. If you just read the news, the LinkedIn, Twitter, a lot of the conversation people are having, there are a lot of false dichotomies out there about RAG versus another technique. For example, like I hear every day people are like, okay, RAG is dying and agent is the future, or the long context window is going to be what we really need for making very to answering very convoluted questions, or knowledge graph is the future, or we really have to go to fine tuning or prompt engineering. But what I want to say here is that when we think about RAG in the more terms, this retrieval is not exclusive techniques. As long as you are part of LLM to some knowledge in the question you're asking to the system, then it is to me a RAG system that is trying to find the best way to feed the relevant information to the LLM. So if you think about all of these above techniques are a way of doing that. Even a long context window is just one way, and that RAG system is just like feeding everything you have in one shot into the LLM. And it may or may not be the best approach depending on where, like which application you're targeting. So why is this still very difficult? Let's answer that question. Is it because we don't have enough techniques to make RAG better? And that is certainly not the case. So this is just taken from one blog. If you just search RAG techniques on Google, you'll get tons of articles of my RAG is better. This is the best approach. This has shown to work well on on this data set, or my customers like it. And there's really no shortage of techniques. And every day there's going to somebody come up with a new fancy technology that seemed to have solved RAG. Really asking is that why is there no one size fits all RAG solution? Like why has there not universal Google search or this case? Or why has that not happened? And if you think about it, people are doing that. Like one of the most major ones is, for example, like OpenAI's Assistant API. So when it launched, it takes documents and allow you to chat with documents. It can take maybe a very large size of document, maybe not as much as a lot of the production systems are, but at least it's a universal RAG that's supposed to solve a problem. Solved, but not for all. So why is that? Why is that the case? So there are a couple. The most talked about one is the data diversity issue, which is obviously there's a lot of different types of data that people want their RAG to work with, whether it's financial reports, whether it's legal documents. All of these documents are structured differently, and they have different information density. So naturally, like if you have a single retrieval system that's supposed to find relevant information, it may or may not work. And the other things are a little bit less obvious, which is, for example, query diversity. So even if you have the good algorithm to design it specifically for a type of data, users can still ask any kind of question against that document. And imagine a question like, for example, asking about Harry Potter, the book. And it can say, like, how many times did Harry Potter appear across all the series? And that's a very difficult question to answer versus say, who is the author of Harry Potter? And these two questions, as you can imagine, should probably be handled in very different ways. Or if it's asking about a very specific thing, going to summarize different tasks. So even if the data is the same, it doesn't necessarily mean that one RAG is going to work for that entire use case. The third one is requirement diversity, because each application has very unique requirements. For some of them, you just need to get to an okay answer and provide a generally helpful guidance to the user. But the others, for instance, in a lot of the finance applications, it has to be exactly right, because every time you get a number right, you get a number wrong, the users will immediately distrust any of the answers that you provide. And this whole solution is useless if it's not like 99.9% correct. But for a lot of other applications, if you're like just summarizing like the, user feedback, for example, if you miss the user feedback, it's not really, the end of the world. And lastly, user experience is also fundamentally different across all the different applications. Are you aiming for extremely high latency? Because that would actually disallow you to use some of the more fancier techniques, which are trying to grab the most relevant things using a very convoluted pipeline, because a user may not be tolerant of a 10-second delay in getting the answers. There's all sorts of trade-offs that's in that process. And also, are you allowed to ask follow-up questions to the users to clarify, or all the questions are provided beforehand? So all of these things add to the complexity of RAG systems. And because of that, it's very difficult to say that there's like one universal RAG that's just going to work for everybody. So which RAG is better? As you can probably guess, my answer is all depends. And you really have to figure out yourself which strategy works well in your use case. And maybe it's going to be a couple of strategies in combination that solve your problems. So how to pick the RAG or RAGs that work best for your production application? The easiest solution that people typically take in the beginning is to pick the one that feels good. Like you read about a blog post saying that there's this architecture that is very smart, that makes a lot of sense to you. Then you go with that. So we have a term for that called VDD. It's called vibes-driven development. So you're feeling very good that you're adopting this fancy technique. It must work. So that's the most common approach. Obviously, as you can imagine, it's not very robust or reliable. And an okay solution is actually baking some type of evaluation in that process to judge the performance of the system. So you're not just basing your own judgment, using your own judgment to make the decisions. So you can ask ChatGPT or LLMs to judge each RAG response to see is this answer good enough. But that also, as you can imagine, is not the best approach, because LLMs in itself is biased. It doesn't have full context of your application. It doesn't know what's good and bad to your users. And it doesn't, especially in a RAG context, it doesn't know what's out there. So if a context is relevant, it doesn't mean it's the best one. There may be more recent or more accurate, more correct documents that should be retrieved to answer the question. But the ChatGPT is not going to know that if you just use the naive LLM as a judge approach. So the best approach, in our opinion, is the data-driven evaluation optimization. So even though at the surface level, it's going to feel like it's more work to get started, but we see over and over again from our customers and also a lot of the people productionizing RAG, this is actually the easiest solution, because it may feel like it's a little bit more work to get started, but it get you to an actually working product much faster than any other solution. So I think I've had enough of the slides. So I'm just going to show you like a very specific use case and in that I'm going to explain some of the concepts of how data-driven development work and what are the specific ways to do it. So our plan is to use this data set that's public in GitLab, actually open source their entire employee handbook, which is a very interesting data set. And it's very common for companies to build internal knowledge data to build RAG for. So for example, the GitLab has all of their internal protocols, like for example, what's the expense policy in finance. And so I've downloaded all of that data. And so we're going to build a RAG system for this data set to see, to answer questions of internal employees. And then we're going to obviously build 3 RAG solutions using Quadrant. And this vector database is going to power us for a couple of different RAG architecture. And the last 2 parts, which is the most interesting part, is we're going to do a data-driven evaluation of the retrieval step. And then we're going to do a data-driven optimization generation prompt, because for the retrieval system, it has these are the 2 most important components of it. Okay, let's dive into it. Yeah, so data-driven evaluation, like this first component of it, what's the difference between evaluating the answers based on a data-free approach, data-driven approach, is that, as I alluded before, like the pure LLM-based method where you just use LLM as a judge, it doesn't really have the context. And it doesn't really, understand the intricacies of your application, and it can have the worst case is that you're actually overfitting the preferences to the LLM data that was trained on. Data-driven approach means that you're similar to your applicants, close to how your users actually interact with your product to judge the performance of it. And within data-driven, there are a couple of different approaches. You can use a public data set, but public data sets, again, not really tailored to your application. You can create a human label data set, but human label data sets are very expensive to curate. For those of you who've tried it, you know that you can only create a small subset, and it can't realistically cover all of the cases you want to cover. And synthetic data is actually an approach that Relari really takes for all of the customers, because even have the ads available, this really drastically expands the surface area. Like, kind of with data using a to take synthetic media into outputs, we're going to be the golden data set that has some liquid. So here is how we do in the Relari. And the idea is that you're gonna pick the architecture you're developing application with. In this case, we just do RAG. What you can do is, so I have this whole GitLab employee document wiki that I've downloaded, but for demo purpose, I'm just going to select a few documents to show you what the flow looks like. So you're going to give the generator the context that is operating in. And this is a step that's also very important, which is to provide some seed example data that actually help the generator to create data sets that's very close to how your application works. And lastly, we're just going to create the data set. Let's say like and then questions based on these documents. So this is going to be, taking a little bit because it's going to traverse through the documents and figure out what is the most interesting questions to ask to stress test the system. So, so I've done this last night, and I've created like a 200 data point question, so so that you can directly see what it looks like. So within each question, we're going to have, say, the question. This is synthetically generated, something that people can. The ground truth answers. What is the golden answer? And ground truth context, which is already to be returned. This is most relevant to this application. It'll actually give you, we generate questions from a lot of different types. This one in particular takes a lot of different chunks and combine the information and then use reasoning to do it. So we have this 200 question data set. So now if I'm the application developer, oh, actually, sorry, I feel like the actual tool that shows the data set. Yeah. Chat. This it'll now or all good. So it thematic just turn those no state which is kind of real world 50 and do our and here small early this which I'm not sure through for each it's going to have or and does information. So we call on is all the and the keyword-based retriever retrieved 45%, and the semantic retriever, which is the pure naive RAG, did 72%. So you know exactly how this hybrid approach have improved on this. And another metric that is very important to look at is the precision, which is so the horizontal axis is precision and the vertical axis is recall. Because essentially there usually is a trade-off of like how complete you can get and how dense the information is. Because for example, for the hybrid retriever, we know that it retrieved over 80%, about 80% of documents, but only 25% of the document that it retrieved was actually relevant to answer the question. So this may or may not be a problem for your application, but if it is, then maybe you can use a re-ranker to actually improve the precision without sacrificing the recall. So this is a way to actually get very holistic insights into how well these systems are actually working based on the data set that's relevant to you. And another more granular way of doing the analysis is actually going to the results because we've already created a 200 set data set that has a lot of different types of questions, right? We can filter them by, say, for example, the multi-doc, meaning that the questions that would require multiple chunks in order to answer the question. And you see that the recall is 70%, lower than 80% it has. We can also look at, for example, the reasoning type of questions. And you know that reasoning type of question is a very common one and it seems to be doing fairly average in terms of performance. So with these type of information and granularity, you can actually make a very informed judgment of how well each different RAG strategy is working for you and how to move from there. So let me go back to the slides real quick and we just walk through this. And now I'm going to talk about another concept, which is a data-driven improvement. So let's say you've improved your retrieval part of your RAG pipeline. And now there's the other part that significantly impacts the user experience, which is the final answer generator. Even if you retrieve all of the relevant documents, it may or may not be giving you the answer that you want to provide the users. And all of us who spend a lot of time prompt engineering know that it's an extremely tedious process. But if you have a data set that actually tells you what are the expected input and output, you can actually make this process automatic in a data-driven approach. So I'm going to show quickly how the prompt auto-optimizer works on a RAG data set. But the high-level idea is that you would have a golden data set that have the input and output, which you already have, and then a target metric you're trying to improve against. So the target metric can be something like the style of the answers, or the correctness of the answers, or any particular things you try to avoid. And then the as we actually evolve the prompt gradually. Now it get metric, see how it performs. I saved you the manual work of like experimenting different things, and then something doesn't work until where it's performing set. So how to do that? So like I said, we are optimizing the RAG and we select a data set that is a ground truth. The close prompt and we'll just start simple description costs, right? And here part where we how optimize it. So that we're going to give the LLM is the question and the context. And then we can select a model that we want to optimize for, and then a metric. So here in this case, if I want to optimize for style alone, then I can do that. Okay, now it's running. It's going to take a lot of evaluation and auto improvement. So let's just look at the result that I've completed earlier. So here is the result of an optimized prompt. And you can see it went through 5 steps of iteration. It started with, you're an employee system, GitLab, answer the questions. And what it did was that it gradually added more content, evolved the type of things that you want to say, all the nitty-gritty details, and eventually got to a longer prompt. But the longest one may not be the best one. And you will know that from the data that it shows that, okay, so this is how it performed on this particular style metric. From the process, but you can see that the prompts actually are very different, because it is optimizing for a very different type of data, type of the user requirement, and type of metric as well. Here we'll try to be correct, and you can run these iteratively to get to a good result of your final prompt. So let's see. That's it for my presentation. So to conclude, to summarize what we did, we essentially built a simple RAG system. Then we used data-driven approach to evaluate and benchmark different RAG strategies and understand the trade-offs of different architecture and how to improve from there. And also we use a data-driven approach to improve a component of the RAG, which is a prompt. And this is, I want to say that this is not just the only way to do it. You can use a data-driven approach to evaluate the prompt as well, or you can use a data-driven approach to improve the retrieval part. But in the end, by having these tools and basing all of your judgments on a data set that you trust, it's going to help you iterate much faster and make better decisions throughout this process. Yeah, that's it. And happy to take any questions. I think we have almost exactly 20 minutes left, despite all of the connection issues in the beginning.
Yeah, thank you so much, Yi, for all of that. And apologies for the people in the chat who are asking questions. I was not able to answer them because I didn't want to affect the recording. But if there were any issues with the quality, huge apologies about that. Sorry. Yi, do you mind just talking a bit about why you're using Quadrant specifically to do these tasks?
Hi, Thierry. I don't think I can.
I said, do you mind just talking a bit about why you're using Quadrant specifically for these tasks?
Yeah. I think when you're working with a lot data set, if you want to reduce or large case, Quadrant being just is a perform, and also I think complexes between example I did able to in base and the third prototyping is the environment implementing cloud as well.
Okay, and another question is Ragus and DSPy. What are the comparisons there? And yet we're aware of internet connections. Apologies, please bear with us.
Yeah, Ragus and DSPy are both very popular open source frameworks. I think totally in the direction where we're trying to use it to and improve. Specifically different Metrics, metrics that we are actually very good at evaluating some of the component such as retrieval, where you don't really have to call an LLM to know whether the context retrieved is good enough. And the best approach, in our opinion, is to have the golden data set that covers these different use cases, and then use simple precision recall and traditional search metrics like MAP, NDCG to evaluate the performance. And that would actually be a much more robust and easier way actually to do the retrieval evaluation. And for DSPy and TaxGrad and a lot of the other prompt optimization framework, I think the exact right approach to do it. What we found people having trouble using these frameworks is that you'll still need to really define data set that you're using to optimize the prompts and also the metric as well yourself. But being the company that's specializing in helping people getting the tailored data set ready based on their documents, their use case, and also the custom metrics people need to optimize for. We sort of close the loop to people just do it in one shot and their own data set and in a set.
Cool. And then there was a question earlier about evaluation framework being used underneath. Is it open source?
Yes, we have an open source evaluation framework called continuous eval. And so continuous eval has over 30 different metrics that we've developed for RAG, for education, all time. And a lot of yours, deploying these metrics different. But I would say when we see in production use cases, the most impactful metrics and evaluation framework being used are usually fairly custom and has to be what's more than just the open source standard metrics. Because it's very difficult to write a general metric that just works for every use case. Just like it's very difficult to write a general RAG system, as I mentioned in the presentation. So you can start with the open source framework. For example, with us, like continuous eval or with Ragas or a lot of the other frameworks out there. But we highly recommend that you customize these metrics to reflect your unique requirements.
Cool. Does anyone have any other questions for Yi? It looks like people are typing. Let's give them a second.
Mm-hmm. Yeah, thank you, Sam, for linking our.
Yeah, thank you for that, Sam. And I see JMT with the Albert Einstein emoji.
Our framework.
Okay, so someone asked, what are the tweakings you do after you analyze the metrics?
Yeah, that's a very good question. So the flow usually is that you run the aggregate benchmarking across some common approaches, and then you kind of iterate from the best ones from those results. And then what the more granular analysis you can do is to look at the different question types, the different answer types, the context types, and look at failure cases. And the failure cases usually are, something that you have to kind of solve on an ad hoc basis, or you can kind of look at the most high impact ones first, and then design the architecture around that. And the reality is, I think a lot of the use cases, in order to handle a wide variety of questions well, they have to have some type of triaging logic in their application to design different retrieval architecture for different types of questions. Like I mentioned, the summarization question and the fact-seeking question can be in one application. So in that case, you have to have a query classification, that type of things, by knowing that, okay, the current architecture doesn't work well for this type of question. And then you improve based on that using that data set.
And we've got some asking, does optimized prompt also prevent prompt injections by default? Looks like we're having some connection issues. Give you a second to get back. Okay, you're back.
Am I back? Yeah, sorry for the issue with the connections. I'm not sure what's which part of the data pipeline is going wrong today.
Did you catch the question about the optimized prompt by any chance?
I couldn't see the screen right now.
Okay, so Sam asked, does optimized prompt also prevent prompt injections by default?
Oh, yes. So I saw that question. So the answer is it doesn't prevent it by default. What it can do is, like, if you add that as a metric, I want to prevent, prompt injection, and if you have the right data set for it, then it'll actually be able to iterate to a prompt that is very well, like, guarded against any type of prompt injection that you want to avoid. So the way it works is that you can actually iteratively run prompt optimization against different metrics one at a time, or ensemble them together, so that you can have a prompt that is doing very well in each aspect you care about.
You got a few people typing. Thank you for joining us, Ugur. Awesome. Cool. So I'm looking forward to see what you build. JMT says, I'm sure we're going to see a lot of prompt validation and sanitation from the LLM providers in the near future.
Right, certainly. Yeah. But I think the prompt engineering still falls on the application developer. And people have different protection they'll need to have for different applications. Yeah, thank you, Sam. And for those who want to try our platform directly, you can either use the open source version, which has the metrics, or go to our website directly, where you'll get all of the different tools. And the reason we didn't decide to open source the more advanced features is because, like, every application is so tailored to the specific data set. It actually makes sense for to have the tool that in a cloud version that leverage that data set specific to you to be able to make the improvements that you hope for. So I recommend for the best experience, it's to use the cloud version.
Awesome. And thank you Twiro for the kind words. Of course, if you want to use Quadrant, you can go to quadrant.tech. We've got a 1 gig free cluster for life. You don't need a credit card to get started. Start building something with Quadrant and Relari today. And once again, apologies for the technical issues. I saw, I believe it was Sadiqer, JMT, Sam, anyone who had any technical issues. Thank you for your patience and bearing with us. Okay, we got time for a few more questions. Docker deployment's working very well for homebrewing stuff. Awesome. I'm glad to hear that. Are you building anything particular with the Docker? Hey, Gabrielle. Thank you. Is the Quadrant Colab notebook available? Yi, will that be available?
All right, I didn't get the question.
Is the Quadrant Colab notebook going to be available?
Yes.
CMPS Cabral? Yes, the notebook will be available. What do you think about the Anthropic workbench? And also, and it's, I'm assuming he meant to say, and it's great prompt creation platform.
Yeah, I think I really like the Anthropic, and essentially we'll be able to have like a very sophisticated prompt from the get-go by just typing a few words, and it's a very starting point. And what it doesn't do is that it doesn't really know what you need that prompt to be and what you're solving for. All it does is to kind of write its some details. We always see customers doing is that they actually use Anthropic to more sophisticated that prompt, initial prompt in the Relari optimizer, and then using a data set through that, move out all of the errors, the sentences that you don't need in it, and add sentences that actually should be important for your task.
Okay, so JMT is trying to build a RAG that can evaluate real estate prices, but there's a lot of different problems, especially the listing site not wanting me to scrape all their data. And Sam says that, yes, evaluators are still missing over there at the Anthropic workbench. Yeah, no, the scraping, that's the big roadblock in a lot of these projects, right? It's just getting the data. Data is oil.
Yeah, totally. Clean status is what everybody hopes for. And I think some of the RAG applications couldn't even get started because there's no good parsing to begin with, or that particular type of data. Class of problem that we have to solve.
Yeah. I mean, they can stop us, or they can't stop us, but they can annoy us. Yes, exactly. Exactly. Okay, we got time for a couple more questions if anyone wants to chime in. All right, looks like Sam's typing. I'll let Sam have the last word. Thank you for your patience, Sam. I know you were having issues. Appreciate you sticking with us. And thank you to everyone who joined. We had over 100 people participate in the webinar, so thank you. Waking up early to come watch us code.
Yeah, really appreciate the Thierry, and thank you, and sorry again, like Nash's. Yeah, hopefully folks were able to get bits and pieces here that is helpful.
Yeah, next time we'll do it at a dedicated T1 line somewhere. Thank you, Sam. And thank you, everyone, for joining us. Once again, thank you so much for your patience with the technical difficulties. We'll make sure that next time everything is a lot more smooth. Hopefully you got stuff you can take away from this. We'll be sharing the collab link. It's Yi from Relari. Go to Relari. You can check out his product. I'm Terry from Quadrant. If you go to Quadrant, you can sign up for a free cluster, get 1 gigabyte for free, and start messing around. Thank you very much, and have a wonderful day, everyone.